Here you are, you have just written your first Hello World program. You run it and it works. You think, ha, this programming stuff is easy. What is all the fuss about? Or maybe I'm just smarter than other people. You start building some more programs and applications, realizing, okay, it isn't as easy as I thought. While working on your code, your mood flip-flops between why am I doing this to myself and I am the smartest human alive. You've already learned all about variables, conditional statements, loops, functions, and even added a cool colorful theme to your IDE. Surely that is all you need to be a successful software developer, right? One night you stumble upon a YouTube video about data structures and algorithms. Looks interesting. Wait, what the hell is that? Do I really need to learn that? And that's the question we're gonna answer today. Do I actually need to have a good understanding of data structures? I'm gonna leave algorithms for another day. Today we're just gonna focus on data structures. In my opinion, the answer is very simple. Yes, you need to learn about data structures. Thanks for watching everybody and see you in the next video. No, I'm just kidding, of course. There is a bit more to it than that. Yes, you need to learn about data structures, but you don't need to have such an in-depth knowledge that you can calculate the complexity for everything and for each operation. That's definitely not necessary. When you have a good understanding of data structures, it can be beneficial even without knowing the math. Different data structures are important for two main reasons. First, reducing the complexity of your code to make it easier to understand and maintain, and second, performance. Let's take a quick look at a simple example. I'm gonna do this in C#, but keep in mind everything you learn about data structures is applicable in pretty much any modern language. There are small differences from language to language, but the general concepts are always the same. Let's just make a class here called person. People usually have names, so let's put a string here. I'm also gonna add a boolean whether a person is subscribed to my channel or not. Now I add 10 person objects to an array. Each one has a name and is either subscribed or not. Let's say I want to find out if Daisy is subscribed to my channel. I need to make a loop and go through every object in the array until I find the person with the name Daisy. And then I can check whether or not she is subscribed. Alternatively, we can use a data structure called a dictionary. I added the same 10 people to this one. But instead of being objects of the class person, they are now just a pair of a key and a value. And now if I want to check if Daisy is subscribed, I can simply get the boolean value by using her name. We now just went from having a separate class to store our data, looping through the objects, getting their names and checking each one, to a single operation. What we did here is reduce the complexity of our code. It is now easier to understand and maintain. As a bonus, we also sped up the whole process enormously. Instead of doing a bunch of operations to find one value, we just need to do a single one now. In our simple example, this speed increase isn't directly noticeable of course, but when you start working with more elements, differences in the data structure can be the difference between your program taking 2 days to complete or it taking seconds to complete. A performance increase doesn't always have to result from less operations in your code though. How memory is used by different data structures also plays an important role. It is important to note that this isn't always the case. We don't always get less code complexity together with higher performance. Oftentimes it is a push and pull between the two and you need to decide where you want to make trade-offs. Either you keep the code more maintainable or you increase the performance. For example, when you use a list you get lower performance than with an array, but you can dynamically increase and decrease the size of the list, unlike the array which has a fixed size. This can result in easier to understand code. If you are working with small amounts of data, the performance aspect often is negligible, and you can just focus on writing cleaner code. But if you are working with large amounts of data and you need your code to be scalable, you might have to write more complex code to get the most performance possible. Of course, there are a bunch of data structures out there apart from the dictionary, and each one excels in different situations and use cases. Chances are, if you're trying to solve a problem, there is a good data structure for that specific use case. In university, they will have you implement data structures from scratch in exams, but this is not necessary at all. As with pretty much everything in programming, you don't actually need to know everything by heart. You just need to understand the underlying concepts. So the next time you're trying to solve a problem, you can pick the correct tool for the job. This is the most important thing you should take away from this video. Data structures are simply tools you can use when you are trying to solve a problem. Depending on the problem, a different tool is needed. A shovel in Minecraft can be used to break stone, it is just way less efficient than using a pickaxe. Learning about data structures simply means that you are adding more tools to your arsenal, and I guarantee that this knowledge will make you a better developer. Also, this knowledge will help you in pretty much any programming language. Even if you have never used C# before, you can always just search creating a dictionary in C# or you can search creating a set in Java. To reiterate what I said before, you just need to have the concepts in the back of your mind. How to actually use a data structure in a specific language is always just one search away. And that's it for today, guys. If you thought this video was helpful, you can give it a like, it really helps me out. And if you want to see more content like this, then subscribe to the channel. And yeah, see you in the next one. Bye bye.